Welcome back. In this teaching video, I'm looking at 4.3 roots of a quartic equation. 4.3 represents chapter 4, section 3 of the core pure 1 textbook. Let's have a look at the key facts of this section. Let x equal alpha, x equal beta, x equal gamma, and x equal delta be the roots of the quartic equation. Ax to the power 4 plus bx to the power 3 plus cx to the power 2 plus dx plus e equal to 0, where a, b, c, d, and e are constants and a is not equal to 0. Consider the quartic ax to the power 4 plus bx to the power 3 plus cx to the power 2 plus dx plus e. We can factor out the a and we can write down that this quartic over here is equal to a in bracket this quartic over here. Now the roots of the quartic inside the bracket are x equal alpha, x equal beta, x equal gamma, and x equal delta. Hence the factorization of this quartic inside the bracket is x minus alpha, x minus beta, x minus gamma, and x minus delta. We can continue with the algebra. We can expand these four brackets and multiply by a and then rearrange to get this quartic over here. Hence, this quartic over here is equal to this quartic over here as written over here. Now I can compare the coefficients of x cubed, and if I do that, comparing the left and right, I can see that b is equal to minus a in bracket alpha plus beta plus gamma plus delta. Hence, alpha plus beta plus gamma plus delta is equal to minus b over a. That is the first important information. Now, if I compare the coefficients of x squared, I can see that c is equal to a in bracket alpha beta plus beta gamma plus gamma alpha plus gamma delta plus alpha delta plus beta delta. Hence, I can make this bracket the subject and I can write down alpha beta plus beta gamma plus gamma alpha plus gamma delta plus alpha delta plus beta delta is equal to c over a. Now if I compare the coefficients of x, I can see that d is equal to minus a in bracket alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. So if I make this bracket the subject, I get the following result: alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta is equal to minus d over a. And finally, if I compare the constant terms, I can see that e is equal to a alpha beta gamma delta. Hence, if I make alpha beta gamma delta the subject, I get that alpha beta gamma delta is equal to e over a. So that was the first important information. This is the second important information, followed by the third important information, and the fourth important information. So we've got four key boxes over here. We're going to be utilizing these four key boxes within an example and some exam style questions. Here is an example. Alpha, beta, gamma, and delta are the roots of the quartic equation 4x to the power 4 plus 3x to the power 3 plus 2x to the power 2 minus 5x plus 4 equal to 0. Without solving the equation, find the values of part A, B, C, and D. Okay, so let's have a look at the solution. First and foremost, we're going to read off the coefficients. So we can see that A is equal to 4, B is equal to 3, C is equal to 2, D is equal to minus 5, and E is equal to 4. Let's have a look at the solution to part A. So we want to work out the value of alpha plus beta plus gamma plus delta equal to, we know that, and this is given by minus b over a. So I've got minus b over a equal to minus 3 over 4. Moving on to part B. Now I want to work out the value of alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. This is given by c over a. So I've got 2 over 4, which is equal to a half. Moving on to part C. So in part C, I want to work out the value of alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta. So this is given by minus d over a. So this would give me minus 5 over 4, which is equal to 5 over 4. Moving on to the final part of the example, part D. So now I want to work out the value of 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. I can combine this into a single fraction, so I can do the following. The fraction will be over alpha, beta, gamma, delta. We have to multiply top and bottom over here by beta, gamma, delta. So I've got beta, gamma, delta. Plus, we have to multiply the top and bottom of this fraction by alpha, gamma, delta. So alpha, gamma, delta. Plus multiply the top and bottom of this fraction by alpha, beta, delta. Plus multiply top and bottom of this fraction by alpha, beta, gamma. Equal to, now this one over here was calculated in part C. It was 5 over 4. So I've got 5 over 4 over alpha, beta, gamma, delta is given by E over A. So E over A will be 4 over 4. So if I simplify this, I get 5 over 4. This completes my example. Here is an exam style question. The quartic equation x to the power 4 minus 16x to the power 3 plus 86x to the power 2 minus 176x plus 105 equal to 0 has roots alpha, alpha plus k, alpha plus 2k, and alpha plus 3k for some real constant k. Solve the equation. Let's give the solution a structure. I'm going to begin by writing let alpha be the first root. Let beta equal alpha plus k be the second root. Let gamma equal alpha plus 2k be the third root. And finally, let delta equal alpha plus 3k be the fourth root. Okay, using this information over here, we know that alpha plus beta plus gamma plus delta is equal to minus b over a. From the quartic equation, I can deduce the coefficients. So I've got a equal 1, b equal minus 16, c equal 86, d equal minus 176, e equal 105. Okay, so now I'm going to substitute my alpha, beta, gamma, delta into this equation with the b and a. So I've got alpha plus k plus alpha plus 2k plus alpha plus 3k is equal to minus 16 over 1, which is just 16. Now if I expand and simplify this, I get the following result. 4 alpha plus 6k equal to 16, equation 1. Now I'm going to create my second equation using the second important information over here. So I've got alpha beta plus beta gamma plus gamma alpha plus gamma delta plus alpha delta plus beta delta. This has to equal c over a. So I'm going to carry out my substitution. I've got alpha multiplied by beta, which is alpha plus k, and so on. So I've got alpha plus k multiplied by alpha plus 2k plus alpha plus 2k multiplied by alpha plus alpha plus 2k multiplied by alpha plus 3k plus alpha multiplied by alpha plus 3k plus alpha plus k multiplied by alpha plus 3k equal to c over a. So that would be 86 over 1, which is just 86. So I'm going to expand and simplify this, and if I do that, I get the following result. I get 6 alpha squared plus 18 alpha k plus 11 k squared equal to 86. Okay, so that would be my equation 2. Now if I go back to equation 1, I can make alpha the subject. So I've got 4 alpha is equal to 16 minus 6k. Hence, alpha is equal to 4 minus 3k over 2, equation 3. So now I can substitute equation 3 into equation 2. So I've got 6 in bracket 4 minus 3k over 2 squared plus 18 lots of 4 minus 3k over 2 multiplied by k, and then I've got plus 11k squared equal to 86. Right, so I've eliminated the alpha. I've got an equation involving k, so I can solve for k. Now if I expand and simplify this, I get minus 5 over 2 k squared is equal to minus 10. So k squared is equal to 4, hence k is equal to 2, k is equal to minus 2. Now if I substitute k equal 2 back into equation 3, I can work out alpha. So I get alpha equal to 1. In the same way, I can substitute k equal negative 2 back into equation 3 to work out alpha. I get alpha equal to 7. Now I can substitute this pair back into my alpha, beta, gamma and delta. And so if I do this, I get the following result. Alpha is equal to 1 and beta is equal to alpha plus k, so 2 plus 1 is 3. Then we have gamma, which is equal to alpha plus 2k, so that would be 1 plus 2 times 2, so that would be 5. And then delta is equal to alpha plus 3k, that will be 1 plus 3 times 2, 7. Now if I substitute this solution here back into alpha, beta, gamma and delta, I get the same solutions. Therefore, the roots of the quartic equation are alpha equal 1, beta equal 3, gamma equal 5 and delta equal 7. That there, ladies and gents, completes the exam style question. Here is another exam style question. The equation 4x to the power 4 minus 19x to the power 3 plus px to the power 2 plus qx plus 10 equal to 0, where x is a complex number, p, q are real numbers, has roots alpha, beta, gamma and delta. Given that gamma is equal to 3 plus I and delta is equal to gamma star, which is the complex conjugate of 3 plus I, that would be 3 minus I. Part A, show that 4 alpha plus 4 beta plus 5 is equal to 0 and 4 alpha beta minus 1 is equal to 0. Let's have a look at the solution to part A. Let alpha be the first root. Let beta be the second root. Let gamma equal to 3 plus I be the third root. Let delta equal gamma star, which is 3 minus I, be the fourth root. So using this key information over here, we can generate an equation. So I've got alpha plus beta plus gamma plus delta is equal to minus b over a. Let's read off the coefficients. So we've got a is equal 4, b is equal minus 19, c is equal p, d is equal q, and e is equal 10. So I can substitute my alpha, beta, gamma, delta, and my b and a back into this equation. So I've got alpha plus beta plus gamma, which is 3 plus I, plus delta, which is 3 minus I, equal to minus b over a. So that would be minus 19 over 4, which is 19 over 4. Now the plus I and the minus I cancel out. I've got alpha plus beta plus 6 is equal to 19 over 4. I can multiply the entire equation by 4. This gives me 4 alpha plus 4 beta plus 24 is equal to 19. Take the 19 to the left hand side and I get 4 alpha plus 4 beta plus 5 equal to 0 as required. Now I can use this information over here to generate this equation over here. So I've got alpha beta gamma delta is equal to E over A. I'm going to carry out my substitution. So alpha beta, the gamma is 3 plus I and the delta is 3 minus I, equal to E over A, so 10 over 4. Now over here we've got a difference of 2 squares, so that simplifies to 9 minus I squared, and then we've got equal 10 over 4. We know that I squared is equal to negative 1, so alpha beta in bracket 9 minus 1 equal 10 over 4. That becomes 10, so I've got 10 alpha beta is equal 10 over 4, multiply by 4, I get 40 alpha beta is equal to 10, take everything to one side, and then divide by 10. So if I divide by 10, this gives me 4 alpha beta minus 1 equal to 0 as required. This completes part A of the exam style question. Moving on to part B of the exam style question. Hence, so we have to refer back to our answer in part A, find all the roots of the quartic equation and find the values of P and Q. So let's have a look at the solution to part B. So I've got 4 alpha plus 4 beta plus 5 equal to 0, equation 1. And then I've got 4 alpha beta minus 1 equal to 0, equation 2. I can make beta the subject in equation 2. So I've got 4 alpha beta is equal to 1. Hence, beta is equal to 1 over 4 alpha, equation 3. Substitute equation 3 into equation 1. So sub 3 into 1. 4 alpha plus 4 lots of 1 over 4 alpha plus 5 equal to 0. So the 4's cancel out. 4 alpha plus 1 over alpha plus 5 equal to 0. Multiply the entire equation by alpha. I get 4 alpha squared plus 1 plus 5 alpha equal to 0. This can be written as 4 alpha squared plus 5 alpha plus 1 equal to 0. Hence, if I solve this equation, I get alpha equal to minus 1, alpha equal to minus a quarter. Substitute alphas back into equation 3 to work out the betas. So when alpha is equal to negative 1, beta is equal to minus a quarter. When alpha is equal to negative 1 over 4, beta is equal to negative 1. Hence, the roots of the quartic equation are minus 1 minus a quarter, and then we've got 3 plus I, 3 minus I. Okay, so these are the roots of the quartic. Now we want to work out P and Q. So I'm going to use this result over here. I've got alpha beta plus beta gamma plus gamma alpha plus gamma delta plus alpha delta plus beta delta equal to C over A. Right, I'm going to substitute my alpha, beta, gamma and delta back into here. So if I do that, I get minus 1 multiplied by minus a quarter So I'll take alpha to be minus 1, beta to be minus a quarter. Alternatively, I can take alpha to be minus a quarter, beta to be minus 1. It will not make a difference, so I'll get the same answer. But if I just be consistent with alpha equal minus 1, beta equal minus a quarter, that would make my working out make more sense. Okay, so I've got plus minus a quarter multiplied by the gamma, 3 plus I. And then we've got plus gamma, 3 plus I, multiplied by alpha, which is minus 1, plus gamma, 3 plus I, multiplied by delta, which is 3 minus I, plus alpha minus 1, multiplied by delta, 3 minus I, plus beta, which is minus a quarter, multiplied by delta, 3 minus I. This must equal C over A. Okay, so the C is P. So P over A, which is 4. Now if I expand and simplify the left-hand side, I get the following result. I get 11 over 4, and this must equal P over 4. So making P the subject, I get P equal 11. Now I want to work out Q. So to work out Q, I'm going to use this result over here. So I've got alpha, beta, gamma, plus alpha, beta, delta, plus alpha, gamma, delta, plus beta, gamma, delta. Okay, so 1, 2, 3, 4 equal to minus D over A. So carry out the substitution. Alpha is minus 1, multiplied by beta, which is minus a quarter, multiplied by gamma, which is 3 plus I, plus alpha, beta, delta, so minus 1, multiplied by minus a quarter, multiplied by 3 minus I, plus alpha, delta, plus alpha, gamma, delta. So alpha is minus 1, multiplied by gamma, 3 plus I, multiplied by delta, 3 minus I. Okay, plus beta, gamma, delta, so minus a quarter, multiplied by 3 plus I, multiplied by 3 minus I. So this whole thing has to equal minus D over A. So D would be Q, minus D would be minus Q, over the A value, which is 4. So if I take this whole thing over here and if I simplify it, I get minus 11. So I've got minus 11 is equal to minus Q over 4. Hence Q is equal to 44. That's a lot of working out there, but hopefully that makes sense. Okay, so this completes part B of the exam style question. Moving on to the final part of the exam style question, part C. Show these roots on an Argand diagram. So in part C, we are going to show the roots minus 1, minus a quarter, 3 plus I, and 3 minus I on an Argand diagram. So here is my Argand diagram. I've got the real axis and I've got the imaginary axis. Now 3 plus I represents the coordinate 3, 1. 3 minus I represents the coordinate 3 minus 1. Then minus 1 represents the coordinate minus 1, 0. And finally, minus a quarter represents the coordinate minus a quarter, 0. So, my first point, the 3 plus I will be somewhere here. 3, 1. My second point, 3 minus 1, will be somewhere over here. So these are my roots, 3 plus I, 3 minus I. Then I want to label the roots -1 and -1/4. Okay, so -1/4 written as a coordinate -1/4 0 will be somewhere here. And then -1 written as a coordinate -1 0 will be somewhere over here. These are the other two roots of the quartic. So in total we have 1, 2, 3, 4 roots of the quartic. And this is my origin. So that there, ladies and gents, completes this teaching video 4.3 roots of a quartic equation. If you found this teaching video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post a new teaching video.